Alright, so where we left off was we had this matrix, which represented the system of equations. Again, if you don't know how to do this, don't worry about it. I applied I row reduced, got it into reduced row echelon format using Gauss-Jordanian elimination. So what this tells me is that A is equal to minus 1, B is equal to 1, C is also equal to 1. Feel free to pause it now and go through using your method of elimination or substitution, however you want to solve that system, and see if you can get the same answers I got. Okay, so what does this mean? Well, if you recall, what we had was we had something over x plus 1, something over x plus 1 squared, and then x plus 2. So x plus 2. So what this gives us is negative 1 plus 1 plus 1. Okay, and what I'm arguing is if you combine those together, what you'll find is you'll get x plus 1 squared times x plus 2. So this is partial fraction decomposition. This is how we do this. So again, this is an example on what to do if you had repeated factors. So x plus 1 times x plus 1, or x plus 1 squared. This process where you just repeat, you take the factor and then you repeat it with another multiple of it, and then you keep multiplying until you reach the power. That's just the general process. One other thing I'd like to talk about here before I give you some homework. So what happens if you have something on the bottom that doesn't factor? So what if I had x squared plus x plus 1 times, let's say, x, and then 1 up here? What do I do here? Well, again, the first time you're going to put the factors down on the bottom. So x squared plus x plus 1 plus x. Well, we know over here we're just going to have a constant. But over here, what do? If it was just a constant, it wouldn't really work out. So what you actually have to do is you have to do a linear equation. So notice how this down here, this is a quadratic. So it's a second degree polynomial. The numerator would be a first degree polynomial. Notice the little 1 that I don't write there because it's implied. Okay, so that would be ax plus b, and then over here you would just have a c. And then you would go through the same process. So what would happen if I had 1 over, let's say, x cubed plus x plus 1? And let's just pretend that this doesn't factor. And then we're going to multiply that by x plus 1. Well, again, this you could write it this way, x plus 1, and we'll call that an a, plus, and then over here, you'd end up with bx squared plus cx plus d over x cubed plus x plus 1. Okay, so this numerator is entirely determined by the degree of the factor in the denominator. And this only applies when it's an nth degree, so squared or cubed or to the fourth, and it's not factorable. Again, if you have something like this, this is factorable because it's x plus 1 times x plus 1 times x plus 1, and so you'd want to use the method of repeated factors. So x plus 1 squared, and x plus 1 cubed. Okay, and then for each of these, even though this is a squared, you just want a single variable because really it's x plus 1 that we're working with. Okay, I hope that helps. Yes, these are long. Yes, these are going to take a bit of work, but it's really, really helpful if you know this now before you end up in calculus. So good luck.